Thank you for the introduction. As you said, my name is Anne-Catherine, in Norwegian Anne Katrine, and Atle, he's my colleague, is also here, and I'm presenting a paper on behalf of 4 researchers. It's myself and Atle and Cecilia Flyen and Vibeke Mortens. We're all from Norway, but this research is from Svalbard. First of all, I'd say thank you so much for having me here, or having us here, because this is extremely interesting. And our research is, I think, quite different from what has been presented here yesterday, and especially yesterday. But anyway, even though it's a lot of similarities, and I think it's very interesting to follow all the talks. So, okay. This paper, or this presentation, is from 2 research projects. One of them is called Cold Coast, and the other one is called Arctic Alpine Decay, and they are funded by the Norwegian Research Institute. We are all working at Svalbard, and this is a very like Shetland. Actually, it's a remote island, but almost all cultural heritage is wooden, making it extremely vulnerable for the tourism or tourists, trampling tourists, and for climate change. As you can see on this picture, actually there is cultural heritage on this picture, meaning that the cultural heritage is very small in this big, in the big landscape, and almost all tourists are visiting Svalbard because they want to see the nature and the wildlife. Hardly anyone is there because of the cultural heritage, but when they explore the islands, the cultural heritage is kind of not. It's not possible to ignore it because it's everywhere. Svalbard is actually quite big, and it's situated far north. So we usually call it High Arctic, the High Arctic. The climate at Svalbard is called Arctic Desert, but when we started working at Svalbard in approximately year 2000, it was hardly raining at all. A couple of years after, it started raining during the summertime, and now it's also raining during the wintertime. So climate is changing rapidly, and in the north, and especially at Svalbard, climate is changing 2 to 3 times more rapidly than in the rest of the world. Actually, in Svalbard, it's even 3 to 4 times, even more rapidly. This is affecting, the climate change is affecting the nature, which again is affecting the cultural heritage stock. And these are just some of the effects happening at Svalbard at this time. And as the cultural heritage is wooden, fungal decay is extreme, and actually one of the worst degrading impacts is from fungal decay. It usually was researchers thought that fungal decay shouldn't be any problem at Svalbard because it's cold and dry, or at least it used to be cold and dry. And fungal needs humidity and some special types of temperature to sort of thrive. But our research showed that the fungus is quite active actually, and it doesn't go very much more slowly than at mainland Norway. So then we looked into fungal decay and tourism as 2 of the most extreme degrading effects. As shown on the previous one of the previous presentations, tourism is increasing also in Svalbard, even if tourism isn't very large compared to other places on the earth. It's more than enough for the vulnerable nature and cultural heritage at Svalbard. And as you could see, tourism has increased slowly but steadily since it started to be tracked in 1996, and then COVID came and it just fell down to zero because Svalbard was closed, and then it went up again in 2022, and the figures for 2023 hasn't come yet, but they are approximately the same as 2019, and 2019 is the highest that has ever been measured at Svalbard. Svalbard doesn't have any roads. It's quite inaccessible. So going around the archipelago is only possible using a boat or helicopter or snowmobile during winter time. So most tourists are traveling by boat and by cruise ships. Most of the tourists are sort of joining a cruise because especially because of the polar bear danger, it's extremely dangerous to travel alone, and it's difficult to do all the arrangements. So most tourists traveling around Svalbard is going by a cruise. The cultural heritage stock at Svalbard is quite young. The oldest are dating back to the 1600s, the beginning of the 1600s, when whalers started using Svalbard as a summer place for hunting whale. And there is a quite young act called Svalbard Environmental Protecting Act that says that everything older than 1946 created by humans is to be automatically protected. This means that the cultural heritage stock is young and somewhat difficult to understand because it might be just some pile of wood or some stones, and it also might be even garbage, but still protected. The government has quite hold high goals for Svalbard, the environment protection of Svalbard, and it should be the best protected wilderness in the world, and within wilderness also goes cultural heritage. And for special goals for the cultural heritage stock are also quite high, and it should be a representative selection. And what is a representative selection? It's difficult to tell. And the annual loss shouldn't be more than 0.1%. And it's impossible to track or to trace because the cultural heritage is placed all around the archipelago, and it's quite accessible, as I said, and very difficult to keep track of what's happening, actually. So in our research, we visited 11 sites to look at the cultural heritage, both from the perspective of what's happening with decay from fungus, and also to talk to and to observe tourists and how they behaved. These 11 sites, they are situated all along the west coast of the archipelago, or actually the west coast of the largest island called Spitsbergen, because that's where it's most accessible or easy to visit and not that expensive, and that's where most tourists visit. This is just a quick, some small pictures from all the sites, and they were picked together with the governor of Svalbard, because we wanted to have those places that were most visited by tourists, so that we should be sure that there would be any tourists when we visit the place. Okay, so then some findings. We were using methods both from the natural sciences and from the social sciences, because we wanted to look into the fungus as well as the tourists. It might be a little bit strange to sort of understand why we would both look into the natural sciences and the social sciences. But as I said, as most cultural heritage is wooden, and the tourists sort of trample all over them, it was necessary for us to understand how they were sort of in the physical shape of the cultural heritage. So that's why we were looking into the wood as well. And methods for looking into the fungal decay were both, we were allowed to take some few small samples, taking it back to the laboratory and looking into it by a microscope. And then we could track the type of fungus being active. And that was necessary because the different funguses, they have different sort of living conditions, or they want different kind of living conditions, and they make different kind of damages in the wood, and they also are active in different areas of the building or whatever it would be. So that's, if we knew what kind of fungus was active, we also could tell how it appeared in the cultural heritage structures. So that's why it was interesting for us to know. And actually we found that during these projects and during 20 years of research before this 2 projects, we found that almost all structures that we visited, and that was more than 200 sites, were affected by fungus. And it was some places severely affected and some places just a little bit affected. But every site that we visited, every cultural heritage structure that we looked into was affected by fungal decay. And we also found that it was one special type of fungus that had sort of specialized on this at Svalbard, in this special kind of cold and dry climate, which it still is, even if it's raining more. And quite a lot of the sites, especially the oldest ones, were extremely severely deteriorated. Then we turned to the visitors, which mostly were tourists coming from cruise ships, and we interviewed them and we observed them, how they sort of behaved in the sites. And as they were visiting by cruise ships, they were always accompanied by a guide. And the guide was almost always most interested in protecting his or her visitors or tourists from polar bear danger. So that was the main sort of issue when they went ashore. That was also the main issue. As I said, most tourists came to visit Svalbard in order to look into the nature and the wildlife, and especially the polar bear. Even though they always went ashore, almost always went ashore at places holding cultural heritage. That might be because it was easy to get ashore there, but it's also because you are not sure to meet the wildlife because they are wild, but you are sure to meet the cultural heritage because it's there, of course. So the guides and the industry, the tourism industry, they always visit cultural heritage, even if they know that the tourists are most interested, at least in the beginning, are most interested in visiting or in looking into the wildlife and the nature. But after being there, after having visited some of these cultural heritage sites, almost all tourists that we spoke to were kind of affected by the cultural heritage and by understanding a little bit about how it was to stay in this wilderness and to sort of adapt to the wild conditions. So cultural heritage had a significant impression on them, actually. One of the problems we looked into was why we saw that the tourist industry sort of destroy the cultural heritage, and they didn't want to, because of course they wanted to visit the cultural heritage sites, and then they didn't want to destroy what they were visiting. But even though they did, and we tried to understand why, and one of the most certain sort of parameters was that they did not understand that it was cultural heritage, and they did not understand that they were destroying. They were interested and sort of curious and wanted to look into all the strange and different things. And then, like you could see on the left down picture, they were walking into and looking into small objects that sort of attracted their interests. And by doing that, they were trampling on the wood and destroying the wood. That was part of the cultural heritage. And this was not only the tourists doing so, the guides as well destroyed without wanting to do so. They were quite, the guides were actually quite knowledgeable. They knew much about the sites. They knew much about the history. They knew much about how had stayed there, how many polar bears they had killed, how many foxes they have collected, but they didn't know anything about how to behave, actually. And they sort of, they destroyed what they were going to explore without wanting to do so. This made us understand that the cultural heritage is destroyed by one of the industries that is supposed to be there, because the governor of Svalbard wants the tourism industry to be an active part of the Svalbard society, and it's a wanted industry. And at the same time, as I said in the beginning, the wilderness is supposed to be protected as the best in the world, and that's extremely difficult to sort of combine. So, and we also saw that there was a lot of gaps holding, or the governor didn't know anything, or didn't know enough about what was happening, and they were not active enough looking into what's happening. They have no monitor system. There's a lot of monitoring on the wildlife, but nothing on the cultural heritage. So they don't know what's happening, actually. And we found that there were a lot of methods that should be developed in order to sort of get the knowledge and be able to have a knowledge-based management. Also, we saw that because of lack of knowledge, for example, they didn't know that there was fungal decay. I don't know what they thought it was, but they didn't know that it was fungal decay. So when sometimes they wanted to repair the huts, for example, that were still standing, and they did restore work, and I don't know what they did, because not knowing that it's fungal decay means that they could have used methods that was not feasible, and the fungal decay could still be there and could still be active. So it's a lot of both methods and knowledge that is lacking. And also some of these structures are very decayed, very hardly anything left, and they still are open for the public or for the tourists. and this is not very well. We don't have. They are not documented. We don't have the sort of collected the knowledge that we could from these sites. So documentation is something that they should do as well. Some of the sites are documented using 3D documentation, and they work very well because 3 of these places are now lost. So because of erosion and fungal decay and tourism, there's nothing left. And it goes even faster with the climate change. And there is also a really lack of awareness, both, as I showed, amongst the guides and amongst the tourists. And this is kind of is really sad because they want to explore them. And I think that's one of the most important values connected to the cultural heritage sites, that it's possible to explore them for humans. And so I think they should still be visited, but they should be sort of protected by the visitors. And this is not happening today. So to conclude, degradation caused by natural hazards is increasing, including fungal decay. Human-induced degradation is increasing. And those are sort of reinforcing each other. The governor lacks tools to track developments and acquire research-based knowledge. This is very briefly conclusions. And to preserve it's a lot of things lacking. Like I said, knowledge and methods. And the deterioration is accelerating, and we need to do something now in order to still have something left to show to the tourism, to show the history, to show what's happened up there. And those cultural heritage sites are international because they were explored by, or the Svalbard nature was explored by mostly the Western Europe, but also including Russia and the United States. So it's international cultural heritage, and Norway has an obligation to take care of the international cultural heritage stock. And the consequences from both the cultural heritage, the tourism and the climate change is that they are sort of disappearing in an even faster pace. And we need to do something. We need to at least to try to keep them as long as possible. And I think we need to document in order not to lose the knowledge embedded in the cultural heritage stock. Okay. Thank you.
We're well familiar with the sites, discarded newspapers and takeaway cartons and bags of dog poo, frequent sites no matter where we live and work. Of course, in many such places, how do I move forward? Sorry. In many places, of course, it's completely forbidden. But we're not deterred because we say to ourselves, well, everybody does it. It may be reprehensible, but it's very low-level criminality. Our debris dropping probably won't be noticed and is unlikely to be traceable back to us. The evidence is likely to turn up remotely from where we actually drop the stuff, and many reckon it's more convenient to litter than to take home and dispose of it. But citizens' messy habits are but a different version of communities and commerce and countries treating their environment badly. I want to focus on 2 sites, on Shetland here and on Svalbard that we've just been hearing about. Each of them important, not least because they hold some esteem in the public imagination and in polity as being places of significance. As the book associated with the BBC series Wild Isles says, all life on Earth is interwoven, and wild islands hold crucial threads in one great global tapestry. And one feature of this is the remarkable range of natural life, from wildflowers to over 100 species of migratory birds, in Svalbard's case, as well as Arctic foxes, polar bears, reindeer, and so on. The research interest in Svalbard relates often to the significant number of species on Norway's threatened species list. Equally here, it has to be said, these islands have had a fascinating and unique natural environment involving a truly Shetlandic collection of bird life, sea mammals, wildflowers, and wonderful beaches. In each case, one of the recognised threats is from pollution, from the passing of currents, or from coastal dumping. It's said here that a majority of the time the waste doesn't come from the sea, it was actually poured into the waters from the land. The archipelagic nature of both Shetland and Svalbard invites us to see sea and insular land masses as interrelated. Maritime environments with their own ecological changes and challenges, coastlines which are, of course, liminal spaces, a state of constant change and hybridity. But of course, throughout the whole thing, the truth is that sea and coast alike are impacted by anthropogenic factors, not least, I want to say this morning, by marine and coastline debris. I want to, in a sense, lump them together in another sense as being, however vaguely, part of Norden, part of the Nordic world. And of course, Norden has traditionally seen itself and be seen by others as front-runners in environment and climate policies. And they often come across as being on a mission, driven by their own environmental goodness. Svalbard is often referred to as being a wilderness, with many of the connotations that go with that. The incoming Svalbard environmental regulations just alluded to speak of the territory as one of the largest wilderness areas left in Europe. The place has long been mythologized in many ways, but particularly as unknown, inaccessible, and forbidden land, remote, wild, and othered. Shetland, too, in a sense, qualifies for the description in many ways of wilderness. Northlink's online Shetland travel guide, my reading material for coming up from Aberdeen, asserts that here nature appears in her wildest dress, one of the last unspoiled wildernesses, though I appreciate that hyperbole is a key feature of tourism writing. Wildness may be imprecise, but it's a strong concept in its appeal to our sense of beauty, albeit more rugged than refined. It's a sense of timelessness, natural habitats, we say. And perhaps that's why we have, in a sense of bereavement when they're threatened or lost, whether from climate change, deforestation, or a creeping requirement for farmland. But the threat of damage that I want to focus on is the one of litter. There's always been debris associated with human living. Where would archaeology be without the exploration of the midden? The legacy of the garbage of those who went before us. It's not new, but I think with the coming of plastic, there's a new, more enduring, highly persistent and dangerous threat. Plastic is now ubiquitous in terms of much of our everyday living, the bags in which we folk cart our home, our shopping, the utensils and tools in our kitchen or elsewhere, the bottles that contain mineral water, the packaging and ties that keep them shut, and all sorts of goods now contain hidden plastic pellets, the beads added to personal care products, the synthetic fibres in our unnatural clothing. One might go on endlessly. Until quite recently, human-made objects in the sea or on beaches were primarily made of natural objects: wood, paper, cloth, rubber, with some glass. But human-made materials, it said, now outweigh Earth's entire biomass. At the present rate of accumulation, plastic is expected to outweigh all the fish in the sea by 2050. We've witnessed it in our lives. To school, many of us took our pencils and rubbers in a wooden pencil case. Our unwrapped sweets were weighed out on scales and transferred to a paper poke. Our satchels were made of leather and our clothes were of natural fibres. No longer. It's plastic that rules, and the plastic that we need to dispose of. Between 60 and 80% of all marine debris comes from plastic products and packaging. Conservative estimates suggest that 8 million metric tons of plastic find its way into the world's oceans every year. And this means that once it's present in the marine environments, because of its character of having a high level of permanence, this pollution will have far-reaching impacts on organisms and on ecosystems for years to come. For all its flaws, plastic is a miraculous class of materials. Cheap, elastic, lightweight, durable, capable of taking on almost any shape or colour. You can stretch it into a sandwich wrap, or harden it into a car bumper, or mould it into an intravenous tube, or spin it into a t-shirt. The list of plastic is boundless, and of course bound to us. But we imagine that we rid ourselves of it. You drink a Coca-Cola, well, other brands do exist. You throw the bottle into the bin, you put the bins out on collection day, and you forget about it. But it doesn't disappear. We now go to hell in a plastic carrier bag, an item that is so constant, and yet whose worth is valued at 10 pence in Scotland. And while its damage around a seal's body or a whale's stomach is inestimable, that's the reality. The routes by which debris comes into our waters is varied, but inevitably a great deal of it is maritime related. Nets and traps accidentally fall overboard, or they get discarded, or they get detached. One way or another, they continue a kind of ghost existence, ending up entangled in marine animals and in the ingestion of alien material. And it's understood by public authorities, a little quote from a member of Shetland Islands Council. An increasing level of marine pollution from discarded fishing is apparent in the waters around Shetland. And the finger of blame, of course, very often gets pointed at the fishing industries, both important industries, both in Shetland and in Svalbard. Just as plastic is ubiquitous generally in a range of different forms, it's also growing, so that plastic production is on a constantly upward trajectory. plastic production is projected to double by 2045 and reach, I don't even know what this figure means, reach 1.1 billion metric tons. I don't have a mental picture for that. It comes in form of larger plastic that damages institutions and equipment, that contaminates beaches and harbours, that messes up coastal grazing and creates safety risks at sea and on the land. But a rather different order of things comes when we get into the realm of nanoplastics. Vast amounts of microscopic particles of plastic debris break down. They don't disintegrate so much as divide, splitting constantly into smaller and smaller pieces of themselves until we imagine that they don't exist. While some microplastics are manufactured as microplastics, others result from fragmentation, from all sorts of anthropogenic sources. Macroplastics become microplastics, become nanoplastics, and by then they're small enough to enter into our bloodstreams, our brains, and the placentas of unborn children. And we see them in the birds that fly around famously these regions. Sorry, what's that? Durability of plastic may be one of the strengths of that it has, but it has downside. The downside of durability is that it doesn't, as I say, biodegrade as most natural products do. You may remember this little incident a few years ago where some containers fell off a ship and they broke open and they spilled out into the ocean nearly 29,000 bath toys. They were intended for rougher waters than domestic bathtubs, but they were now liberated and literally at sea. Like the legendary Flying Dutchman condemned to roam the seas eternally, these little plastic ducks were either washed up on shores or doomed to an eternal maritime existence. Plastic can travel a real distance. Some of these little ducks end up spending years in Arctic ice before reaching the United States eastern seaboard, and actually also making it to Britain some 15 years later. But floating capacity of plastic also means that all sorts of things can use them as passenger vessels, carrying exotic species from other places and a potential route for introducing non-indigenous threats. And this can be exacerbated by the fact that with climate change, sea ice is shrinking, and this creates new routes for pollutants to travel, meaning that, for example, in Svalbard, there is now a higher level of pollutants than there has ever been before. They form in garbage patches, and oceans are becoming rather crowded spaces with debris forming a significant element in swirling currents that concentrate plastics in these garbage patches. And that means that on the face of things, paradoxically, it's often more remote islands that have the worst plastic pollution. And one of the big threats to animal life is, of course, entanglement. It's estimated that each year around 1 million seabirds and 100,000 marine mammals and turtles are killed by plastic. Problems arise when air-breathing animals become entangled in fishing net and drown, or are cut, maimed and killed. Not pretty pictures. And of course, sometimes the nice shiny plastic looks like food, and they end up ingested. And of course it has direct consequences. Dietary dilution, they fill up with non-nutritional stuff. It causes internal damage by perforation and blockages of the gut, and it introduces to their bodies chemicals and toxins. Sea turtles eat floating plastic bags, mistaking them for jellyfish. And whales die through all sorts of plastic pollution. I mentioned birds. While once birds used to be a sentinel species in the coal mine, now they're sentinel species of our polluted world. Research carried out between 2003 and 2007 found that 95% of fulmars had plastic items in their stomach. What can be done? Well, of course, we see the problem and we try to tackle it, first of all, I think, by clean-ups. But it's a big problem. Sally Huband, who wrote Sea Beam and is a beachcomber, referred to the swathes of plastic that had been washed ashore in Shetland. And so efforts like the clean up in Shetland under the auspices of the Shetland Amenity Trust and its equivalent on Svalbard of the Svalbard clean-up, Norwegian clean-up programs are an important thing in trying to counter the effects of beach debris, but also, I think, giving us an informed sense of the extent of the problem. In a sense, I think collectors are, if you like, volunteer scientists in examining what's the problem. Recognition, I think, comes from international organisations. KEMO is a network of local government organisations in 8 countries, founded in Denmark, to prevent pollution and to protect, preserve and enhance the seas. And I put the slide up simply to illustrate the role of public and other organisations who are committed to engaging with challenges. An important role in that, here's a project, the Same Boat project, where they are in trying to bring in a level of awareness and accountability, and in fact giving back the polluters some of the mess they've created. One of the key principles is said to be the polluter pays, but that's not often true. So, 60 seconds, if that. The practical challenge is an important one, but the issue of environmental litter is a broad and deep one. If you like, it's a symptom of the Anthropocene. It requires a fundamental rethink of our priorities. So to conclude by going to where I began at the beginning, I commented that Norden is generally regarded as a front runner in environmental things. Lea Wermelin, was sometime Minister in Denmark of the Environment, said that Denmark sees that it's urgent to get in place a long-term solution. We will continue, she said, with our Nordic leadership for a new agreement. And here in Shetland, the chair of the Environment Committee said, throwaway plastics are now a problem globally and locally. I'm sure that we all want to reduce plastic pollution in our seas and beaches. I hold back from commenting on the politics of either place, but we need urgently to find common cause and shared interventions to protect the fragile environment of our islands and our coasts in the north.
Thank you. Yeah, thank you very much. So yes, I'm very much sticking to the sort of Shetland Svalbard theme, but also picking up on a lot of what Anne-Catherine was talking about, looking at some of the climate change threats to heritage, speaking about one of the same projects and actually one of the same sites as well. So I'm looking at two sites here, one in Shetland, one in Svalbard. They're different sites, they're in very different environments, and they're very, very different heritage, but they are facing similar threats driven by climate change. And some of the approaches that we're using to tackle those threats are quite similar as well. So yeah, as I said, there's two sites, just to give you a sense of where they are, with apologies for the projection of the map, but I think it does show at least that Svalbard really isn't very high Arctic compared to Shetland down here. So the first site, Chanarwick, is actually slightly south of us, not a word, not a cardinal direction we've said much about so far, but even though it is so far from Svalbard, it really is facing some quite similar threats. And the projects are really working with similar aims in terms of addressing some of those climate change threats, because it's not just the increasing temperature that climate change brings that are shown by the changing colours of the climate stripes that are alarming all of us so much, including poor Doyle the pug here. That's not the only threat, it's bringing with it other things. Sea level rise, of course, is a locked-in impact of climate change. Whatever emission scenario we're in, we are going to experience some extent of sea level rise. So that's going to increase erosion, and particularly in the Arctic, where it's coupled with melting permafrost and increasing soil instability, as well as the loss of sea ice, which is inducing more wave action. That's going to accelerate coastal erosion. And even here in Shetland, that loss of the Arctic sea ice could have an effect by increasing wave fetch and giving us higher waves and accelerating erosion here as well. So both projects I'm talking about really have sort of similar aims of undertaking site-scale risk assessments using archaeological value, site condition, looking at threats to build towards a holistic sort of risk assessment at site scale, really to help us understand the threat in order to inform mitigation strategies and sort of future sustainable preservation options for these sites. So the first one is the site I'm presenting on my own behalf. It's a site I've worked on as part of my sort of PhD research, and it is just south of here on the Shetland South Mainland in Chanarwick Bay. It's a southeast facing bay, just a few miles south, and it's a broch site, but it's a broch that was completely unknown prior to being exposed on the coast edge in a storm in 2013. And if I say broch, you're probably thinking, how on earth did they not know it was there? Because we've seen Musa several times already in this conference, the sort of iconic Iron Age stone tower. Chanarwick didn't quite look like that, so it had sort of fallen through the gaps in terms of being understood, because it looked like that, really. The height of the tower had been reduced by robbing and quarrying for the local settlement. The entire north side of the structure had been completely robbed out right down to the foundation level. There's nothing left of it. So there's no above ground expression of this heritage at all, but following the storm in 2013, the local landowner reported it, and we developed a project in partnership with the Shetland Amenity Trust and Archaeology Shetland, along with the Scape Trust, who I was working for at the time, to investigate this sort of newly exposed structure in the coast edge. And it turned out to be a broch. So it could originally have looked like Musa, but as you see, it didn't look quite that impressive by the time erosion, stone robbing and 2,000 years of degradation had got to it. But to sort of talk you through what we had, so on the south side of the section, which is the left side of the slide, we had the remains of the outer wall. Essentially, coastal erosion had given us a slice through the middle of the base of this Iron Age structure, just to the sort of lowest levels. So we had the foundations of the outer wall on the south side, which was 5 metres wide. We couldn't actually investigate the centre of the wall because of a nesting foamer chip there. We didn't want to disturb it, and we didn't want to get ourselves covered in foam or vomit either, of course. But there were possible hints of an intramural cell in there, right where he'd chosen to have his nest. As I say, the north side had been completely robbed out, but we did have the internal area of the broch. As I say, the coast edge erosion had basically given us a slice through it. So we had a central well that Simon, particularly, I hope will remember very fondly. You were 2 metres down there, I think, and it carried on going at least another metre. We also had a metalworking pit just there, as well as central hearths, floor levels and occupation associated with the initial broch phase. And then there was a subsequent period of modification where piers were inserted sort of in the form of radial spokes to turn it into the sort of later Iron Age wheelhouse structure. And we also did a programme of dating as well as sort of cleaning and recording of the section, which gave us dates of, I think, 3 to 200 BC it had been constructed and occupied up to about 2300 AD as well. So after this project, we were fairly certain it was a broch. It didn't look like much, as I say, but based on comparisons with Musa and other better preserved Shetland brochs, looking at proportions and the thickness of the walls, it actually had the structural stability to have stood to something of the height of Musa, which gives you a sense of how this would have looked in the landscape. So it had been partially mitigated, I guess, the sort of climate impacts by that 2015 investigation. But we do still have a half a broch in the coast edge there, just behind this eroding coast. It is still very archaeologically valuable, and the community interest was ongoing because after that project finished in August 2015, there was lots of ongoing monitoring from the local community. Archaeology Shetland members would go down, take a look and monitor change for us as well. As I say, there is still essentially half a broch behind the coast edge there. So that's the site I selected for the sort of pilot application of the methodology I've developed as part of my PhD, really, because we know quite a lot about it, but there's still a huge amount there, and there's so much sort of interest in doing something more there. So back in August 2022, I flew my drone all around the bay, and using a technique called structure from motion, just taking low-level overlapping aerial photos, about 70% overlap. There's a very clever piece of software which turns those two-dimensional overlapping photos into a high-resolution 3D model. It sort of calculates the 3D geometry. So from that, we got a high-resolution, accurate 3D model of the Bay of Chanarwick, of the whole bay. So that's the ortho photo on the left and the digital elevation model on the right. So that gave us the exact location of the coast edge in 2022. And I brought that together with various historic survey sources as well, from the sort of 19th century maps up to more recent records, aerial photos, and all the survey data and records we gathered during our work there in 2015 and around that investigation there. So I was able to get really a picture of where the coast edge had been from 1878, which was the earliest map, all the way up to 2022. And then again in a mapping programme, sort of cast transects, perpendicular transects across all those different coastlines in order to calculate statistics on the rate and extent of change across those different time periods. So the longest one was 145 years from the first edition Ordnance Survey map to the more recent survey work. And what that showed really was that they'd managed to build the broch in the area of coastline which had eroded the most. That is the most vulnerable area of coast in the entire bay where they managed to build their broch. Not that it would have been a particular concern for them at the time, sort of 2,000 years ago when they were building it, because at the long-term rate of change indicated by that sort of 145-year long-term comparison, extrapolating that over the 2,000 years, the coast edge could have been about 100 metres away. So they weren't thinking of this as being a particular threat for them. So we're able to calculate the areas of the bay that have suffered the most and how much has been lost on the site of the broch and the overall amount of land that's been lost to erosion in that period. But then also using some of the more recent surveys that we did around the time of our investigation, as well as high-res aerial photos, we're able to work out that of the sort of 14.5 metres of loss we'd seen at the Broch site over the 145-year period, more than half of that had happened around the period of those storms which had first revealed it. So between 2008 and 2014, we'd lost 7.5 metres of coast edge on the site of the Broch. And by comparing that episode of loss to meteorological records, we've actually identified the series of storms which were probably responsible and can account for the vast majority of the loss and erosion there. So that gives us a sense of the future conditions that will pose a threat to the rest of the site. So that also highlights sort of both how episodic erosion is, but also the sort of spatial complexity, because it was just that one part of the bay, unfortunately, the most archaeologically important and sensitive area, that took the hit from those storms. So it really sort of underlines, I think, that you really need that site-scale data in order to look at site-scale impacts and do sort of site-scale risk assessments. But subsequent to that, between that latest data from 2016 and my survey in 2022, nothing changed. It just seemed to have more or less stabilised. The coast edge had recovered until March last year, when Archaeology Shetland went down. Janet, who's in the audience, I think it was you, who spotted in March last year that one of those central piers had collapsed in a storm, taking with it some of the sort of cultural material from behind it. So Archaeology Shetland, being a truly fantastic bunch of people, went down, recorded it, and a member who has a drone was able to fly the same area to my sort of specifications that I provided, replicate my survey flight from 6 months earlier as close as possible. So I was able to then build another 3D model from his data and integrate that into the risk assessment, which showed that after this period of stabilisation, we'd lost another half metre just in that 6 months between my survey in August 22 and his survey in March 23. So what we have there is sort of community-generated data actually being integrated into high-resolution monitoring and management data, sort of building on that legacy of long-term stewardship on that site. So even though it has sort of partially been mitigated by investigation there, and we have these 3D landscape models and some sort of preservation by record, we do still have a half Broch left in there that is still very vulnerable and eroding. And at the sort of long-term rates of change we've seen, that what's left in there is probably going to be gone by 2050. So hopefully some of that monitoring data that we've gathered can help us to make an informed decision about future management strategies for the site, and also developed a methodology that can then hopefully be used to look at sort of other threatened sites around the coastline as well. So that's my site. I'm going to move on now to Svalbard. So this is a site that I'm presenting on behalf of Vibeke Martens, who is also Anne Catherine's co-author as well. So you're going to hear more about Colt Coast, but from a different perspective really of coastal erosion. So one aspect of this project was really to look at climate change impacts as well as the development and tourism pressures we've been hearing about, because as we've heard, the Arctic really is undergoing some of the fastest measured changes. It really is the sort of canary in the coal mine, to pick up on Jack's metaphor, of climate change. This is where we're seeing the highest measured changes, and particularly the impacts there are with the melting of permafrost and the loss of sea ice driving coastal erosion. So we've already seen this site. It's a very different heritage from what I was dealing with in Chanarwick. It's sort of early 20th century, and it's industrial. You've got a coal mine up the top, a cableway that worked its way down the coast to an intermediary station, and then a cableway station, which is where the coal was transported onto ships for export, and of course that's right on the coast. This is, I think, quite representative of a lot of the heritage on Svalbard. And part of Colt Coast was to specifically look at impacts on specific heritage sites, and that really highlighted some of the climate change impacts here on this site, was particularly the erosion threat. But importantly, the site was also, I think it is fair to say, quite highly valued by the local community, because it's still in use, I believe, as a polar bear lookout, and we've heard how important that is in that area. And because it's right across the fjord from the largest community, it's very visible, so it's got quite an iconic status, as well as its symbolic value and its heritage value. So it is very highly valued locally. And it was also selected to sort of look at its vulnerability to erosion for all of those reasons, as well as for its heritage reasons. So fieldwork over several years took a series of shoreline measurements and did erosion studies. And you can similarly track erosion here using aerial photos and then a series of high-resolution drone images as well to really underline the very rapid threat of coastal erosion here, that sort of soft sand and gravel plain in front of the site that's being very rapidly eroded, particularly, I think, due to the impact of that melting permafrost. And as I said, it is particularly important to the local community as well. So I think there's a real feeling that something needed to be done about the potential loss of the site. So it was prioritised for further work. But I think that sort of interest was sort of slightly unlike that sort of desire to do something and find a solution around, slightly contrary, I think, to the sort of strategy of curated decay, which had been the sort of strategy in Svalbard up to that point. But because of the value and the threat to this site, there's a real focus on doing something about it and find sort of sustainable management solutions. So firstly, the small smithy building, which you can see in the background there, is a much smaller building. In 2021, the erosion threat was such that it had actually had to be physically picked up and moved inland, because in 2021, one corner of the building was actually overhanging the eroding coast edge. So that's a sort of slightly out of situ form of preservation was done there. And at the same time, there were sandbags put up in front of the cableway station to sort of temporarily form some protection from coastal erosion. But of course, sandbags are a very, very temporary measure as well. So the further part of the preservation strategy that was used here, which builds, I think, particularly on what we heard from Stephanie earlier this morning, was digital preservation, a sort of ex situ preservation by record. So the whole structure was recorded through photogrammetry, so again, structure from motion, as well as a programme of laser scanning. So you've got inside and outside models, which are mounted on the Sketchfab website. The link is down the bottom there, but if you just do a Google, you'll find it, and you can explore the site in 3 dimensions online, and all of these numbers are call-outs that you can click on to learn more about the site and about the heritage. So it's now shared online with lots of interpretive materials, both sort of inside and out. This high-resolution model that's been created and forms at least some sort of preservation ex situ, or preservation by record, which allows people to sort of understand and appreciate the heritage, because in Svalbard it really is relatively quite inaccessible heritage. Because that really is, I think, the issue that we find ourselves facing in Scotland, and that we're finding in Svalbard and all across the world as well. I've got colleagues from Tanzania to Florida to Svalbard, all facing the same issue, which is really, what do we do in a world where in situ preservation has been the presumption for so long, but in the face of accelerating climate change, it's becoming increasingly unfeasible and impractical. And we heard from Simon yesterday about the protection of scheduled monuments. And as we've heard in Svalbard, everything up to 1945 is protected, but climate change impacts fall outside of that regulatory framework. What can we do to protect a site when it's natural climate change impacts? So we're starting to ask questions about, does it make sense to preserve in situ anymore? And when and how do we intervene? How do we decide to make those interventions and do that sort of mitigation? So hopefully some of the methods I've presented here have shown that we can help to do a sort of risk assessment, bring together archaeological value, condition, state of preservation, look at those different environmental conditions and risk factors to do a sort of site scale risk assessment and feed into a holistic risk assessment, which really can help us to understand the sites, understand the threats, the urgency, and really help us to prioritise and make some of those difficult decisions about when and how to take those steps to mitigate those climate change impacts. and start to think about sustainable preservation solutions for some of this very threatened heritage. So I'd just like to finish by thanking all of my friends, colleagues and collaborators from all over the world, and a particular thank you to Archaeology Shetland, who've been there's some wonderful members in the room and who've been so key to doing a lot of the work that I've presented here in Shannon today. So thank you very much.